We're going to now move on to single displacement or single replacement. There are two types. One is a cation and one is an anion. So for the cation displacement, we're going to use the metal activity series. You don't have to memorize this metal activity series. Just understand the higher you go up, like up the lithium, the more reactive you become. As we can see here, sodium on up will react with cold water, produce hydrogen, and that will be explosive. I'll show you sodium will be one of my demos. From cadmium up to magnesium, it will, with steam, so hot water steam is going to produce hydrogen. From lead to cobalt, you need acids to produce hydrogen, and then above that, they do not react with water or acids. So like example, gold, which is good, right? So gold's not reactive in that situation. Or platinum, there goes your, or silver, there's your jewelry, right? You don't want it being that way. So we're going to use this metal activity series. So our first one is single displacement or single replacement, and it's again dealing with the cation displacement. So we're going to focus on the cation. So single displacement or replacement stands out because there's, on the reactant side, I have an element and I have a compound. This is the only one that does this, has an element and a compound. So to figure out what type of displacement I'm working with, I look at the element. So my first one, I have SN10 and I have sodium. So those are my cations. So I go back to the actual list and I find SN and I find sodium. Sodium is above SN. Therefore, SN is too weak and it cannot kick sodium off. Therefore, we're going to say no reaction. Next, zinc. Zinc and the cation is hydrogen. So we go back to the table, we find zinc, and we find hydrogen. Now zinc is by itself, and it can kick off hydrogen because it's higher up on the actual, on the metal activity series. I give you that series, by the way, again. But again, we go zinc kicks off hydrogen. Now poor little hydrogen gets kicked off by itself. We know hydrogen by itself is H2. Now H2 was not drug over. H2 is, I needed two hydrogens to zero out my sulfate. On my reactant side, H2 on the product side is because it's diatomic. They just happen to work out that way. My zinc's a +2, sulfate's a -2. They come together in a 1-to-1 ratio. Next one, potassium. Potassium is higher up on the metal activity series and it kicks off calcium. So calcium is by itself. Can calcium stand alone? It sure can. Now potassium is going to join up with the chloride. Well, potassium's a +1, chloride's a -1. They come together in a 1-to-1 ratio. And yes, we need to balance it. Sodium and water. Now water, we break down to H+ and OH- in this situation. So sodium does kick off hydrogen, and sodium joins up with the hydroxide, and then I have hydrogen by itself. And we have to balance it. The next one, copper and hydrogen. And I want to say this is a no reaction. Yeah, copper is below hydrogen, so it cannot kick it off. I was just trying to remember the metal activity series. It cannot kick it off. So again, this is called double displacement or double replacement. Now there's two types. There's cation. I will give you the metal activity series. You don't have to memorize this, but the second one is anion displacement. And this is, guys, called, we're saying we're playing Halo, because this is just column 17. These are your halogens. So this one you have to know, because you get the periodic table. So how it works, my halogens, fluorine at the top of the column 17 is the king of the hill. Iodine at the bottom is the weakest. So to find out who's stronger, I just look at column 17. For example, I see chlorine and sodium bromide. I have an element and a compound. Right away I know it's single displacement. You can call it anion displacement if you want to, but you don't have to. So I look at the chlorine. Is chlorine higher up than the bromine? Now I'm not looking at sodium here. This is not a caphite. Cation's a caphite. Anion, we're playing Halo. So my halogens are going after each other. So chlorine wants to go after bromine. Is chlorine higher up on column 17? It is. So it's going to kick it off. And since they're both -1, that's going to come together with the sodium with the same ratio. But bromine's now kicked off and Br2. Why? Because it's hot wrinkle. Let me balance it. Next one, individual element compound. Iodine wants to kick off bromine. Playing Halo, can iodine kick off bromine? No, it can't. So I can write out no reaction. Do not complete it, you get it wrong. Next one, fluorine wants to kick off who? Chlorine. We're playing Halo, going after halogens. So fluorine wants to kick off chlorine, and it can because fluorine's the king of the hill. And so we're going to actually get the same ratio there. We don't have to balance this one. So this was an example of single displacement. There are two types, cation, you need a metal activity series for that, and I give it to you. And then we have anion displacement, that's just using column 17, you're playing Halo. Cations is a cat fight, Halo, halogens, you're playing Halo. The halogens are going after each other. The last type we'll talk about is combustion. Combustion is really the easy one. It's we're going to only deal with complete combustion when we go through this. So you're going to have a hydrocarbon plus oxygen yields carbon dioxide and water. So you know the products every single time. Right when you see a hydrocarbon and oxygen, you know, oh, carbon dioxide and water. Then all you have to do is balance it. Sometimes people find it easier for this one to actually use the algebraic technique, but you don't necessarily have to use it. Again, number 2, I see a hydrocarbon, and then I see a plus oxygen. Right away I know it's combustion, CO2 plus H2O. Those are by default your products. All you have to work on are just the balancing of it. So it's a 2 to 9 to 6 to 8 ratio.